Where is this really? It is
Okay, so I'd like you to get your notes out. We got some extra review. I want to get your notes out and go to page 9. Okay? So here we go. Check your understanding. Right there on the top of the page there, I've drawn the circle I just erased. We're getting comfortable with that. All right, an angle in standard position has a measure of 2.7 radians. In which quadrant is the terminal side of that angle? Now, radian measures do not have to contain pi. They often do because of that fundamental relationship that pi radians is half a revolution, 2 pi radians is a full revolution. But they don't have to contain pi. So if you think about this for a second, we know that pi decimally is 3.14. So half a pi would be what? 1.57? Is that right? So if we want an angle of 2.7 radians, won't that be somewhere in quadrant 2?
Yeah.
Okay, perfect. The radius of a circle is 8 inches. A central angle of the circle has an arc length of 26 inches. What is the measure of the central angle in radians? Oh, we did this yesterday. How big is that angle in radians? Anybody remember? Remember, arc length is radius times radians, because every, my scale isn't right, but every 8 units of arc length is a radian. So if we have 26 units of arc length, how many radians would that be? 26 eighths? Or 13/4? So your central angle is 13/4. Arc length equals radius times radians. 13/4 radians. 13/4 radians. Remember, this angle is in radians, always. Radius times radians. That's your arc length. Okay?
Yeah, that makes sense.
Never degrees. Okay? All right, an angle in standard position has a measure of 4 pi over 3. Find 3 coterminal angles. Now, I can't remember, did I use that word with you yesterday? Coterminal?
No.
No. Okay, so let's talk about what that means. First of all, here's our circle. 4 pi over 3, you know where that is. That's like right here. Right? So that angle in standard position is that one. Now, coterminal, you can probably tell from the word itself. Coterminal means they share the terminal side. So in other words, you want to come up with another angle that starts here and stops here. Can you visualize what another angle would be that has the same beginning and end? How about that one? Does that start and stop in the same place as the original? So if the original was 4 pi over 3, can you figure out what the green one would be? Somebody said it.
2 pi
negative 2 pi over 3. Remember, Joe, when we rotate this way, we're negative. So one such answer, one coterminal angle, would be negative 2 pi over 3. Remember, we're talking about periodic relationships. So there's lots of angles that are gonna stop in this very same place. Can you think of another one? What about this blue one? Does he start and stop in the same place? Luke?
You did 10 pi over 3?
Luke says 10 pi over 3.
Yeah. Yeah.
Oh, 10 pi over 3. Luke, how did you do that? I think you're right. How did you do that? What were you thinking?
It's just an extra rotation.
Mhm.
It's 2 pi.
So, exactly. So, that blue angle I drew, I went all the way around and then did my 4 pi over 3. So in other words, it's 2 pi, that's your revolution, plus your 4 pi over 3. So Luke got a common denominator here and said that's 10 pi over 3. Perfect. Kids, notice that this first one we got was 4 pi over 3 minus 2 pi. And this one is 4 pi over 3 plus 2 pi. Could we get another one?
Yeah.
Raina's sitting there going like this. Could we get infinitely many?
Yeah.
Yes. We are going to take our original angle, which is 4 pi over 3, and we are going to add or subtract 2 pi. If you add 2 pi, you get Luke's angle. If you subtract a 2 pi, you get this green one. We could add 2 pi's, so 2 spins. So that would be 4 pi plus 4 pi over 3, which is what? What is that? 16/3? How do we find coterminal angles? We add or subtract revolutions. If we were working in degrees, we would add or subtract 360. But in radians, we're going to add or subtract 2 pi. Okay, everybody got that? Okay. The 12 points are all equally spaced around the circle. Angle 1 in standard position has a terminal ray that passes through point A. If the measure of angle 1 is 7 pi over 6, where's point A? Which one would be point A? Well, we know that. You can look at my labels up above, or the ones we did earlier. Everybody know where 7 pi over 6 is? Like right about here? And then where's negative 5 pi over 3? Negative 5 pi over 3. Well, is it all the way around? No. How much short is it? It's going this way, but isn't it pi over 3? If you go negative 5/3, wouldn't that be the same as doing positive pi over 3? Come on, don't just stare at me. Are these brains working here? All right. Go to page 11. All right, we kind of talked about this yesterday. Okay, here's pi pi over 3. For that angle, if we were gonna make a triangle in there, it says that the cosine is 1/2. So if we're in the unit circle, this means your x coordinate is 1/2. The cosine is x. Now, you have to find another value, at least, let's find one first. Another value, another point on the circle where the x coordinate will be 1/2. Think about that for a second. What would be another point on the circle whose x is exactly the same as that one? Well, wouldn't it have to be down here? Where do you think it is down here? Right here? And what's that angle? 5 pi over 3. Beautiful, beautiful, beautiful. So that point right there has an x that's 1/2. That x is gonna match that x. Now, so far we've got pi over 3 and we have 5 pi over 3. Are there any other angles that would have that would be at that same point or this point? Are there any other angles that would be graphed there? We just talked about it. What are some other angles that would be graphed in one of those two places? What'd you say, Raina? Actually, -5 pi over 3. Because how do I find coterminal angles? I add or subtract 2 pi, which in this case would be 6/3. So if I subtract 6/3, here I could add 6/3 and get 11 pi over 3. How many answers are there? Infinitely many. And if we want to write them all, the angles that have a cosine of 1/2 are pi over 3 and all of its coterminals, and 5 pi over 3 and all of its coterminals. Now, what happens at 4 pi over 3? Any idea about what that x value would be? Exactly, that's going to be negative. And what about at 2 pi over 3? That one's also going to be -1/2. So at all of the pi over 3 angles, your x is going to be 1/2. It just depends on whether you're going to be positive or negative. For an angle in the second quadrant, the sine is 0.3. So there is some angle in the second quadrant, and the sine is 0.3. Take a look at that triangle and see if that makes sense to you. Not that this is the only way to do the problem, but does that make sense to you? Because sine is opposite over hypotenuse or y over r. Can you find the cosine and the tangent? Raina?
For the last one, why wouldn't of the like where the 1/2 is, why wouldn't have that been 1 and the hypotenuse been 2?
You absolutely can do that.
Oh,
So,
really?
yeah, with your trig functions, it's the ratios that are important. So, since they were specifically talking about an x coordinate, I went ahead and put it in the unit circle so that the x thing was the actual x coordinate. If I put this, if I label it like you want to, that's okay. That's still gonna be the same angle, but this point is not gonna be 1/2 comma. This point is going to be 1 comma. Okay, and the cosine isn't 1, it's 1/2. Okay, so over here, if I want to, I can make this 0.3 and this 1. That is gonna be exactly the same situation. So if that makes more sense to you, do it that way. If it makes more sense to you the other way, do it the other way. It doesn't matter. I need to know my cosine and tangent though. So what am I gonna need to figure out? Regardless of how I label it this way or this way. How am I going to find my cosine and my tangent? What am I gonna need to know? The other side, so I'm gonna use the Pythagorean theorem. It's easier for me without the decimal, so I'm gonna use this one. What's this gonna be? The square root of 91. And because it's in quadrant 2, it will have to be negative. Now, we want to find the cosine of this angle. We already know the sine is 3/10. They told us that. What's the cosine going to be? Adjacent over hypotenuse. And what's the tangent going to be? Opposite, so 3 over negative root 91. Was it necessary for them to tell me which quadrant this was in? Yeah, because I don't know, without knowing which quadrant it's in, I can't get my positives and negatives right. So, yes, that was good that they told me that. All right, now, let's look at this next one. Our circle back up here, and this is 0 and pi over 2. Now, if I draw a unit circle, this is a unit circle, can you tell me the coordinates of these points? Now, I know the angle is 0, but what are the coordinates of that point in terms of an x and a y? 1, 0. And this one would be?
1, 1.
Not 1, 1.
Or 0,
0, 1. And this one would be negative 1, 0, and 0, negative 1. Is that okay with everybody? That makes sense? That's a unit circle? Okay. Now, keep in mind, what is your definition of, let me see what problem I'm doing, of sine? We have a couple of different definitions. One is opposite over hypotenuse. What's the other one? Y over R. Those are written right there at the top of the page, guys. We need to know that. Y over R. So your job is to look around this picture, understanding that the radius is 1, and find the angle where the sine is negative 1. Where does that happen? Where y is negative 1, and where does that happen? At 3 pi over 2. Isn't y negative 1 at 3 pi over 2? So the answer to question 3a is 3 pi over 2. Now what about b? Where is the cosine negative 1? Pi? It's the only place. Ooh, tricky one. Where is the tangent negative 1? Now be careful, tangent is y over x. think about this now for a second. You want that to be -1. So doesn't that mean y and x have to match? Only one's positive and one's negative? Okay, wait, so if one's positive and one's negative, then we are looking either here or here. Would everybody agree with that? And these two have to match. What kind of angle is that going to be if these two have to match? 45, 45, 90? But I'm in radians now, so I'm not going to say 45. I'm going to say pi over 4. Very, very good. Now, be careful. I can't say pi over 4 because pi over 4 is in quadrant 1. And I need to be the pi over 4 angles in 2 and 4 to get the negative. So what is this angle right here? What's the pi over 4 angle in quadrant 2? 3 pi over 4? And what's the one down here? 7 pi over 4. Julia?
How do you know it's pi over 4?
Well, pi over 2 is 90. So pi is 180. Half of pi is 90. Half of that will be 45. So half of a half, 1/4. If the cosine of 280, if the cosine of 280 is 0.174, so 280 degrees would be like right here. What can you tell me about the cosine of 260? Okay, so this was 280. This would be 260, wouldn't it? And the cosine, which if I'm going to have a radius of 1, the cosine can be my x value, 0.174. What's this x value then? That's the question. What's that one going to be? Negative 0.174. Very, very good. Negative 0.174. We have symmetry, so 10 degrees this way, 10 degrees this way. Those x values are going to be the same. Only this was negative because of the quadrant that it's in. Excellent. All right. Homework 3.2 is going to be due on Thursday, but I'm going to go ahead and give you this little extra practice. I'm not sure we need it. Quizzes are one of those problems, yeah. Quiz is one of those problems. So I needed two together. I'm not assigning this. We're going to work on this as needed. Your homework is due on Thursday. You have a little quiz. Wait, do I see one? No. Yeah, quiz is tomorrow. Homework's due Thursday, but I don't see one. All right, this is some extra practice with 3.2. And we have a few minutes, so let's run through it as much as we can. A couple of these things we already did today, so I don't think it's going to be an issue. Let's look at number 1. The terminal ray of the angle intersects the circle at point P. So P is xy, Q is x negative y, that makes sense. What is the sine of theta? Well, what's your opposite side? What's your y value? Y? What's your r value? 7. So what's your sign? Y over 7. Y over 7. Number 2. Coordinates of P are 4, 3. What are the coordinates of Q then? Negative 4, 3. So over here's Q, negative 4, 3. I know my radius is 5. What is the value of the cosine? Cosine is what? X over R. So what's the value of the cosine? Negative 4/5. Number 3. What's the cosine of that angle? He's got a whole bunch of junk in that picture. Answer the question. What is the cosine of the angle? I think somebody said it over here. X over 3. Guys, this cannot be confusing. Cannot be. This is the point x comma y and the radius is 3. What is cosine? X over r. X over r. It's that easy. Period. Cosine, x over r. Regardless of all the other junk he's got going on. Alright, number 4, last one. Coordinates of P are 5, 12. Radius of the circle is 13. What is the tangent of theta? Now notice, theta is all the way around in quadrant 3. So you need to look at point R. What are the coordinates of point R? Negative 5, negative 12. And we want tangent. What's tangent? Y over x. So negative 12 over negative 5 or 12/5. Okay, that's enough for now. Good job. That homework is due Thursday.